Hi, today we're talking about using the Arduino chip to control the motor. So in this picture, it looks a little bit messy. Bear with me because this is just a prototype. So on the right side, we have a 7-segment display where it's attached on a breadboard and then connected with the Arduino, and also there are some buttons and LED lights that can help you analyze how the pins are behaving. And in the middle, we have the Arduino in the bottom. I believe this one is the Mega one kind of the Arduino, and then on the top, that's the motor shield to control the motor, which is on the left side. And if you can see on the leftmost, there's a green little thing. That's where the shaft is. So like whenever you send signals here, then the shaft is going to turn. That we're going to see how it behaves. And also, I believe this is a DC brush motor. Of course, you can switch to brushless ideally. And for this motor shield, you can attach actually up to 4 motors at a time, and also 2 stepper motors too. And we're expecting to see something like this. So when I press the button on the right and on the left side, the little green thing is going to turn reversely. So let's dive into the coding of this. And for that, we need a header file. And if you've downloaded the Arduino IDE, then it's gonna include this Arduino header file. You can download it from their official website. And before this, there's just one last thing where you need to make sure like what kind of Arduino model that you bought. So there's like pin outs for a different one, especially you want distinguish between the PWM, the pulse width modulation pins, and also the analog pins. You can also get it from like I believe when they send you the Arduino chip. And so let's go back to the code, and we're gonna need this header file. So we if and define this motor potentiometer header file. If it's not defined, then we're gonna define as below. And first we're gonna define a bunch of variables. First and foremost, this is the PWM. The one we're using is L293D shield pins, and it has enable latch clock data for different pins. And for the Arduino pulse width modular pin, we put this 4 are very important. You have to figure out in the pin outs where they are, and we have 4 motors here. And for each motor, we're gonna have a because we use it depends also on the modular that you bought, but usually they use either transistors or H bridges to put the modular, so that for example, this one is a shift register 74HC595. The pins is for like the 8-bit bus, so we use either high or low to get the direction of the bridge. So we have A and B for each motor, and we have 4 of them. And for the direction, we have forward, reverse, and either release or brake. If the release doesn't work, then use the brake, or the other way around. And this one, we can also, if you want, also make using 2 buttons with both forward and left, or forward and right. Then you need 2 buttons. We're not gonna touch on this in this video, but it's gonna be like a minor adjustment in our code. And then we're gonna have this class of, we call it motor turn, and for the public we're gonna construct the class, and we have one function, reverse button, and we're gonna deconstruct this class later. And for the private part, we have a direction function where we're going to take a motor number, remember we have 4 of them, and motor pins A or B, and the direction forward or reverse or brake. There's 3 parameters, and for the shift right one, that's how the modular, the motor control tells the chip, the Arduino board, and we're gonna have motor pin and then the state with either high 1 or low 0. So these are the functions that we're gonna implement on the left side, our C++ file. So in the beginning, we're gonna include the header file, the Arduino header file, the class, and we're gonna have this function reverse button, and we want to define the pin number, so we're gonna define this 52, which is where we connected with the button to control the motor. And we have 2 LED pins. Actually, I already changed the name down here. So one, we want to use it for the speed LED. I think it's this one. And the other one, we're gonna use it for, we call it alert LED, because remember our function is to reverse. Or like some cars, when they reverse, they're gonna have some sort of beep 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 to alert people to stay away, and they're reversing the car. And for this one, we're gonna do the speed. We're gonna say it in a second. And we're gonna set the reverse button state as 0, so it's false by default. And the value is where we're gonna get from the analog pin number A0, and the sensitivity of it would be the potentiometer value. It depends on like how you can adjust this to how much sensitivity you want, but because the potentiometer is from 0 to 255, and yeah, and also speaking of the potentiometer, it's basically like the resistors. It depends on how much the resistor you want over there for the current. I believe the unit is ohm, so that's how we define the speed. And we want to use this PWM pins. So we use this ref pin as input, and our alert and speed as the output for our LED, so that you know how it behaves. And so we're gonna read from the button state, so that if you press the button, and then we're gonna send signals to this ref pin, and this digital read this is gonna send it to the chip, the brain of the Arduino, basically. So if initially it's gonna be low, if it's low, then we're gonna use another function that we're gonna implement a little bit later, and we're gonna use the motor number 2. Remember, we have 4 of them, and we have motor 2B, which is remember we have either A or B to set the difference so that we can have the direction, and we want it to be going forward by default. And we use the resistor, the potentiometer value, to adjust the speed LED, adjust the dimness of the light. So as the resistors goes more, and then the dimmer the light goes, and we're gonna analog write it on the LED. And for the alert, initially we're gonna put the alert low because we're not reversing yet. So in the else statement, we're gonna make it reverse and use the pin A. So we digital write the speed LED to low because we don't want any speed there. We only want the alert one high, so the alert light is gonna be on, saying like we're reversing. Here the serial.print is for, sometimes, especially if you're doing on a breadboard, it's not connected very firmly, then it's better to put this on so that okay, the button is responding, or the board is responding to the button. And also we need to print out the value of the potentiometers. It's from 0 to 255, and if you divide it by 4, then it's in a certain range that you can see how much is being adjusted there. And then we wanted to delay a little bit, 2000 milliseconds, so it's like 2 seconds, so that it won't like pop up on your console like all the time, that you couldn't really read anything. And if you also want to put like left and right button, you can add it down there too. And for the direction function, we want the motor number, which motor, because we have 4 of them, and it's kind of more it's clear if you put like for each motor you want it certain behave how the way it behaves. Otherwise, if I have 4 of them and it's gonna behave really like irrationally, and I think that's not what you want. And you have the pin number, you have the direction command, and now we're gonna have some variables, motor A and B. Remember, we have 2 state to set for 2 pins, the current in and out, so A and B, and the speed, PWM, pause width modular. And now we're using this one again. So this is actually, we can put it as like a global variables way up there. And now we want to switch cases between different motors. So we want to put them under the same name, so that whenever you want it to behave the same way, then no matter which motor was attached, then you want it just to be motor A or motor B. By default, it's gonna break, which means it's not just gonna do anything. And also we want the motor pin, mainly because to make sure that the A and B to adjust the speed for each motor again, and remember the default. And then we want the directions to be forward, reverse, and brake. So if it's forward, then we put the motor A. Remember the A what we got from earlier, that we put on each motor is one of the pin as A, the other is B. So we put one as low, one as high, and the potentiometer value as the speed, and the log write it to the PWM. And so now we have this. If we want reverse, then we just reverse the high and low. And if we want brake, then we put both of them as low, so it will brake. And again, if you want add left and right for steerings. And last but not least, we have this shift right, which is how the motor, you call it shield or modular, is controlled, or how like it sends signals or is controlled by Arduino chip. So we want put the motor pin and the state in there. And we have this latch copy static int, and we have a shift register initialized. Default as false. If it's not initialized, then we use this shield pins for shift register. So we have 4: enable, latch, clock, data as output. And we're gonna set all 4 of them as low in the beginning, and also the latch copy as 0. And then we initialize it to true. And once it's initialized, we're gonna write all the variables here. So we bit write the latch copy, the motor pin, and the state. And then we shift out. This is also an Arduino function. And for the first parameter, we put motor data, so the shift register, serial in, parallel out, and the motor clock, the clock pause 1 bit at a time. And we wanted to use the most significant bit first, that is the leftmost first, not the least. significant, the rightmost first, and then the latch copy. And then we're gonna delay a microseconds of 5, and we have the latch pause of put it high for 5 microseconds and then low. So these are our functions here, shift right, and we have our directions, and we're gonna use this reverse button function up in here. So the last file we need is the .ino file, which is the one the Arduino recognizes. Well, they're also like actually programmed from on top of C++, so that's why it's very compatible. Although you can also write some Python files, they also have a modular to sort of connect with Arduino. So we include our header file and we initialize our class motor turn, we call it M. And then in the setup, we zeroed up begin. This is basically for the serial print. And then in the loop, the main part, we gonna get our function m.reverse button. Remember, our function is to use this button state so that whenever you press the button, it's gonna go from forwarding to reversing once you press the button. And also you can adjust the resistor values, the potentiometer, to adjust the LED, to adjust the speed of the motor. And also it's going to show up the alert LED once you get to the reverse mode. So if everything goes well, if there's no bugs, then you should see the behavior of when you press the button. Actually, the button is under the finger, but once you press it, and then you're gonna have the motor moving and the light going on at the same time. Yeah, you can also put this as red lights for alert too. But basically this is how it works, and I hope it helps. And I will link the source code down below. If you have any questions, feel free to comment down below. And thanks for watching. See you next time.